Hey there, welcome to this Data Science Dojo video tutorial series on time series. If you followed along to our automated web scraping meetup video, you would have scraped Reddit user comments every hour and scored the overall sentiment or emotion towards US political news events. Now that you've taken our observations of users' sentiment, which is a numeric value or a number anywhere between -1 to +1, so very negative feelings to very positive, the next thing you might want to do is predict the next few hours ahead to see if users' sentiment will likely continue to fall into negativity or make a turn or change in direction so you can act on it beforehand. This could also apply to customer satisfaction, for example, where you might want to predict, say, a few hours in advance what customers would likely feel, so you know when it's best to pay extra special attention to customers. So in this video tutorial, we'll be covering some basics of how to build a time series model to predict users' sentiment in the next few hours into the future, or from the current or last timestamp in the dataset. We'll be writing this in Python. In response to our viewers, we're going to be building a time series model in Python, as this was a top request from our viewers. However, if you are more comfortable with R, I have included the equivalent R script for you to follow along with. Just see the links below this video to access both the R script and the Python script. So in part 1, in this video, we'll go over reading and indexing our data for time series, checking the data meets the requirements or assumptions for time series modeling, and transforming our data to ensure it meets those requirements. Then in part 2, we'll get onto the modeling part of time series, input our terms, and predict users' sentiment a few hours ahead. And in part 3, we'll evaluate our predictions, and then we'll discuss issues with our model and how we can take this further and learn more in depth. So let's get to it. So these are the Python packages that we'll be using to build our time series model. So we're going to be using pandas for importing and indexing our data as a time series. We'll be using matplotlib to plot, and we're using StatsModels to build our time series model. And we'll also be using statistics to help us calculate the mean absolute error to evaluate the model. So first things first, we need to read our CSV file of our trained dataset as a univariate or kind of single outcome series. We're going to use datetime as the row index. So let's go ahead and use this. We'll just call it hourly sentiment series. Okay, and we're going to use pandas' read CSV function. And we're going to give it our CSV file in our current working directory, our trained data set, which is a subset of our full data. We're going to use the datetime column to index our data, and that is basically the first column in our data set. So starting at 0. And we want to pass these dates, obviously. And we're also going to use this squeeze option here just to ensure it returns a time series. Okay, cool. Now we're going to print this out just to have a quick look at it. We'll save this. And we're going to run it in our terminal. Okay, cool. So it's indexed it properly from what I can see. But another way we can look at this is if we just print the index itself to make sure it's a datetime index. So let's go ahead and do this. So basically print the index. Okay, cool. So our data, or our rows are a datetime index, which is what we need. The next step we're going to do is we're just going to quickly preview the data to get an idea of the values and sample size. And this is a common practice not only in time series, but whenever you want to model some data, you want to get an idea of the kinds of values that you're working with, the kind of headers or features that you have, how many rows you have to work with. So let's go ahead and do this. So we'll comment these out as no longer need them. And we're just going to print the first few rows data, just get a general idea. And since we're printing the first few rows, we might as well print the tail end of this. And we'll also have a look at the dimensions of our data. Okay, let's have a look. Okay, so we have kind of negative and positive values. As I said, this user sentiment score can be any number between -1 to +1. We also have like 19 rows of data, so I wouldn't say this is much data to work with. It's barely anything at all, really. But we're going to do our best to model on the data that we have. So the next step, I guess, is we want to plot the data to check if it's stationary. And by stationary, I mean if it follows a kind of constant mean and variance. So the reason we got to do this is many time series models require the data to be stationary in order to model it. And we basically want to check to see if our data looks a little bit like this. So as you can see, it has that consistent upward and downward movement, and it kind of centers around here. So we're going to check to see if our data follows this kind of pattern. So we use matplotlib. We'll simply plot our data. Okay, let's have a look. Okay, so as you can see, kind of doesn't follow any kind of stationary pattern here at all. It's quite all over the place. So what we need to do now is difference the data to make it more stationary. And then we're going to plot it again to check if the data looks more stationary after differencing. So differencing basically subtracts the next value by the current value. And we're probably not going to difference this more than twice, as it's best not to over difference the data. This could, potentially lead to inaccurate estimates. And we're also going to make sure that we leave no missing values, as this could cause problems, especially when modeling later. So let's go ahead and do this. So we'll do our first round of differences and see if this makes a difference or not. Apply a diff onto that. And we also need to fill in those missing values so they don't cause trouble for us. Okay, and we need to plot this as well, obviously. Okay, let's have a look. I might just show both plots just so you can actually see the difference from the differencing data. Okay. So that's our original data, our original values, and after differencing, as you can see, it's kind of having a little bit more of a consistent upward and downward movement centering around here. I wouldn't say it's fully there yet. I would say that we could probably take another round of differences just to get it more into shape. So let's go ahead and do that. Let's go apply a second round of differences. We're going to take differences from our first differences. And just in case, we'll fill in any missing values. Okay, let's plot this. Right, so that's our original data, our first round of differences, and our second round of differences. Now, it's not exactly ideal, but I would say that from the second round of differences, it's starting to look a lot more stationary than what we had before. So later in the video series, we'll further check if our data is stationary or not, but for now, let's just go ahead. So now that we've differenced the data to make it more stationary, we are ready to move on to modeling, or the modeling part of this series in part 2 of our video series. Thanks for watching. If you found this video tutorial useful, give us a like. Otherwise, you can check out our other videos at Data Science Dojo tutorials.